Let's get going. It's 1 o'clock. Welcome, everybody. Next episode of our HDF Clinic. I checked, there weren't any questions in the Google Sheet. And so let's jump right in. But before actually questions, one correction. I incorrectly claimed last time that the VS Code extension for HDF5 did not work with netcdf4 files, and that is wrong. I just happened to grab a netcdf3 file, and yes, since that is not an HDF5 file, that didn't work. But I have it, you guys should be able to see my screen. I have a netcdf4 file here, and yeah, it works just beautifully, and no issues there. So that was my mistake, and yeah. Any netcdf4 file should be fine with that VS Code extension. Okay, are there any questions other than there are none in the sign-up sheet? Are there any questions up front? No? Okay, good. So quickly, let's go over our highlights, and we also have something new here today. Let's see, announcements. Still a final boarding call for tomorrow's webinar with Scott Breitenfeld on Introduction to HDF5 for HPC. And you can still register for it. It's tomorrow. I forgot I forgot exactly what the time is, but when you register, you will know. VFD Swimmer Beta 2 is still out there. Dana will have to say more about that in a moment. There is a new blog post out by Mr. HSDS, or AKA John Reedy, about HSDS Docker images, the ones that he uses. And as you know, HSDS runs on Docker, depends crucially on Docker. And he talks about the availability on Docker Hub and other container registries and how that ties in with Kubernetes and so forth. So if that's your thing, definitely check that out, and it should also help you should you want to deploy it locally or do some development locally with it. That should get you started. That was it. I mean, on the forum, again, this is a very biased selection. There wasn't really much going on. I mean, of course, lots of issues related to building and Eclipse and whatnot. There was just something that I saw today. Somebody was trying to build language bindings with Go, and the person was asking for he cited some kind of build issue, and I looked at it briefly. I think it basically comes down to old software. I think the version of the Go wrapper or Go bindings that he's using, they are just too old, because if you go back to the Git repo and look at the commit history, I think both bugs were fixed in later versions. They have to do with typecasting, basically. In one case, it's that Go doesn't want to cast an unsigned long to size T, or the other way around. And in the other case, it's something related to H error_T and the relationship with integers. But both issues I can see from the Git history of that wrapper were actually fixed. And the other bad thing is that person, he or she uses Ubuntu 1804 or something like that. It's probably still I don't know if that's still under LTS or still supported, but the HDF5 version in there is 1.10.1, and I cannot in good conscience recommend to anybody to use 1.10.1 in 2022. And so yeah, I would recommend for that person to just get the latest version of HDF5 and of that Go wrapper and give it another go, so to speak, and that should work. Okay, but otherwise, yeah, I couldn't see, there were plenty of questions on the forum, but nothing else stood out to me. And then, since we have Dana here, I thought we'd do a little engineering corner here today. I think there's also a blog post in the forum which maybe Dana can tell us more about it. And over to you.
Well, so for the HDF5 2.0, we're trying to figure out what we want to do as a community for HDF5 2.0. So once HDF5 1.14 releases at the end of this year, that has a lot of ECP features in it, a couple of new VFDs. And then after that, I mean, the one obvious thing we want to do is semantic versioning, hence 2.0 and not 1.16. I think everybody wants that. But then where does the library go from there? What do we do next? And I can think of a lot of incremental things that we can do kind of in the short term. There's some stuff with the API that I think is not a good way of doing things. There's always going to be this balance between how much pain do we inflict on people who want stability in the API versus, do we fix old things or do we carry old bad ideas around forever? I feel like the move to semantic versioning, that's big enough to where we should at least, in the very short term, make the API changes that we want to make going forward, right? So there's a bunch of, it's small stuff, right? It's not dramatically changing the API, but I think that we should actually drop the stuff that we've told people is deprecated. We've been carrying around since 1.6, the 1.6 to 1.8 switch. And so if you haven't updated your software by now, you should do so. That's, I mean, almost 2 decades is plenty of time to update your software, 15 years, I guess. So there's stuff like that. Then there's a few things, there's some functions where we return memory that was allocated by the library, which we generally don't do because that causes issues and people have different memory allocators. And in fact, that's one of the things I think that we should take some time to suss out, is to be better about handling memory buffers as filters reallocate things and stuff like that. As that's going to, fixing that issue is going to involve changes to the VFD layer. I don't like the idea of that the POSIX kind of enshrined with, like, say, their write calls, right? Where you take in an unsigned type for how many things you want to do, and then you return a signed version of that so that you can return -1 as a bad value. I mean, that's like the dumbest use pattern, and we should not be doing that, especially when you want to be a piece of software that handles large things. You want the full number of things that you can address with the size. You don't want to throw half of your type size away because you want to return -1 as the bad value. That's just dumb. And so we should stop doing that, and we should just have every API call return HRT. And also it unifies error handling. Now you don't have 3 different ways of handling, or 4 or 8 or whatever different ways of handling errors. You can come up with a pattern, and then you can enshrine that and then macro it around or do whatever the heck it is you're going to do with our error stuff. Speaking of errors, I think that our way of handling errors in the library is baroque and silly, and we should stop it. There's these major error codes and these minor error codes, and those sound like they would be great. I'll get to you one second, Elena. Let me finish my rant. I don't like inside the library, they're not used consistently. That they were designed to be, there would be this major error category, and then the minor category is like associated with that. But instead, it's just mix and match. People pick a top level category and a minor category, and then there's strings that go with this. And then sometimes the strings don't make any sense because they were designed for the major category. So it's just kind of dumb. And like the major, and really, what do you care about when you're looking at this stuff? As a developer of the library, when I see these error reports come through, and those error stacks are super useful. When people complain and they say, hey, it doesn't work, and they show me the error dump, I can kind of see what's going on without even doing any debugging whatsoever. But I don't care about the major and minor code. I look at the file it came from, which to me is the major code. And then the minor code, who cares? I don't care about that. What I care about is the text string that was dumped out by the person who set up the macro, right? Hopefully that's helpful, right? But that general, I think that stuff is wildly over-engineered, and it's impossible for us to go through and come up with consistency. I mean, there's 600,000 lines of code in the library. I'm not going to fix all of that, and that's just a waste of time. So I think we should just we should simplify those error macros so that they just spit out strings, and they spit out the file number and the file name and line number, and that's good enough. Anyway, Elena, what you got?
Oh, hello everyone. Several questions in continuation of what I asked on forum. I think it will be right time to look at the limits that HDF5 file format has, and one of the limitations I put in my forum reply, probably will not be hard to fix in the code because it's just, you know, how many, but it will be good to review those. Another silly example will be 32 dimensions, right? 32 dimensions came from C, from language limitation. It really has nothing to do with your data. If you want high dimensionality, why not? Because C imposes 32 and Fortran imposes 7. It's kind of, so just reviewing file format. And along those lines, UTF-8 encoding is a big part. You know, we know that it's long depend. Does TG want to collaborate? And if I reapply for this to support us and even participate in this work?
I'm enthusiastic about coming up with an alternative. I mean, I feel like the solution to that is going to look like what Microsoft does for its compatibility, where they come up with, they have like tchar, right? And that basically is, it's a macro that switches between UTF-8 and UTF-16, and we just have to do the smart thing.
No, Dana, this is not the issue. The issue is storage in the format, and strings are not, you simply do not know what the string is and how big it is. And this actually also causes some CVE issues that should be addressed, right? So I just throwing these ideas at you. If you want to collaborate on UTF-8, great, because I think we have opportunity to move library, and I really encourage to review file format limitations, not features, but already issues we have with file format that we know about, and it's all in Jira.
Right. Yeah, that's one of the things I think is also important. The short answer to the question is yes. Like, I'm interested in collaborating with anybody who can move the library forward in a better direction. But as far as the file format stuff, I think that one of the important things that we need to address is the layer that reads metadata off the disk was kind of designed by Optimus, right? That like basically it's going to work and we're not going to have bad problems. And this is the source of, I would say, like more than 75% of our CVE bugs are that are legit concerns, right? Are reading stuff off the disk, because we have these file format structures that say we're going to have, say, like, you know, how many filters are there in a chain, and it works out fine as long as the number of filters matches the number of things that are in the object header. And as soon as you a fuzzer changes the number to say there's a billion things, you're just going to sail right off the end of the buffer when you're parsing it. And most of the ways that we've been fixing these bugs has been adding sanity checks and checking buffer sizes and making sure that we're always reading within bounds. And there's a few areas that are very difficult to fix, and I think we need to go in and fix those last bits. Have a kind of concerted effort to go through and look at all the metadata cache reading stuff, which is kind of nicely isolated to certain areas of the library, and just harden all of that and be safe and sane about it. And then also, I think it's time to start making it harder to use the older versions of things that don't have checksums. That, you know, for a long time we've been specifying like the file format version that makes it kind of likely that your files are going to work wherever you go, right? So we've been telling people like, oh, so we enshrine, like, you know, the default version is like version 1 B trees for a lot of stuff, and those aren't checksums. And it's time to move people to like the 1.8 and 1.10 structure.
Well, you have to be very careful along with changing HR to H error, right? Because I don't remember how many APIs, but a lot of them return HIIDT. I hope you are not changing those, because this will be outcry from the community. It's changing everyone's code. It's not small change. This is one comment. The second comment is, we really hope, and if, you know, the project on multi-threading goes through, the biggest part of it will be to redesign metadata cache and make it multi-threaded, meaning that definitely all clients will be rewritten and very different, you know, approach will be taken, learning from this experience. So I would like to coordinate this work so we're not to support this, that resources are not wasted on this very important stuff. By the way, I'm not arguing about it, but I just appeal to you guys to.
I don't think it'd be wasted though, because so if we did that, we went through and were to do this, then regardless of yeah, sure, I mean, it would get rewritten under multi-threaded cache, but the lessons learned, and if we make a blog post or a white paper about it, this is what we did. Now the code exists in a form that is nice and safe and sane, and we can apply those lessons to the future stuff as it comes in. That this is how you read stuff off the disk so you don't crash the library when we read bad stuff. That these are the strategies that we're going to use for that, and that transcends any particular implementation. And I don't think that these changes are big, right? In general, most CVE bugs, with the exception of there's a few that are tricky that kind of pass through weird layers of library, most are trivial to fix, right? I mean, bin min and I fix those things in a half hour at a time, right? They're really quick. You just have to basically, pass pointers down to, pass sizes down and pay attention to them. And in many cases, the library has sizes and we just kind of were ignoring them because it was written by Optimists. We just assumed that the stuff written off the disk was reasonable. Or that people wouldn't care if they had a corrupt file and it crashes the library. People are just well, whatever. But the CVE people are grumpy because you can use that to compromise machines.
I can tell you from my experience that rewriting 20 metadata cache clients took almost a year. Of course, people have now some experience, but there are clients that don't be so optimistic because you will open the whole can of worms of metadata cache design. And this is
no, I don't think it's that big a change. I think it's really just about, I think this is really I'm not envisioning big changes for this. I'm just saying instead of right now, the way that we address the CV issues is via whack-a-mole, right? As people report them and then we're oh, okay. And then we go in and we fix them. But it's hard to know, especially when people multiply report these things, did we fix that CVE issue, right? Or is it unfixed still? And I feel that if we go through and we just, if we just took a week and just tried to make sure that everybody looked at the cache client code that does the reading, that would go a long way towards ensuring that we don't that we don't have future ones, or that the rate of influx is minimum. I mean, literally half the issues in GitHub are people hitting us with fuzzers. So.
Okay. Well, what are we doing for people who want to contribute to sort of make the code easier to digest, to sort of get their bearings in the code base and so forth? Are we doing anything for them?
Well, one of my things on my to-do list is to come up with basically a contributor's guide, not in terms of this is the steps that you have to take to set up a pull request, but to explain the HDF groupisms in the library, because there's so many things. Like the aforementioned error bits, right? A lot of times we get pull requests in from people outside the company, and they're just kind of random major and minor categories because they copied and pasted the code from someplace else. So we need to explain that sort of stuff and kind of how those error macros work, and things like the func enter macros, right? There's a bunch of those, the big soup of those. How the trace macros work for public APIs. There's all this stuff that's just it's kind of oral tradition at the HDF group, and if you're going to involve a lot of outside contributors, it can't be oral tradition anymore. You have to have people. You have to give people a document. I don't think it's a big complicated thing to write. It's just it takes time, and I haven't had time because I'm working on other stuff. But it's one of the things I think we need to just throw in the doc directory, and just a markdown file that says this is how some aspects of the guts work. The weird HD prefixes, people don't understand that. I want to remove it, but we should at least document that for kind of how our platform independent stuff works, what you're allowed to use in the library and what you have to wrap. Stuff like that is useful to know, because people come from ecosystems where their software isn't expected to run everywhere. As long as it runs on Linux, they're happy. But we have to run on all these quirky Unices, and we have to work on Windows and things like that. And so for us, we care about a lot more portability things than other people care about. So if you're going to use a new POSIX command, for example, you really do need to read man pages for multiple Unices to see how widespread this is and whether this is a good idea, and are there equivalents for other things. And so we need to explain that kind of stuff to people so that their thought process is right when they're working on the library. into where we can point at it. Like instead of us going into every pull request and saying, hey, not like this, we should be able to point to stuff and say, hey, this is, it's in this document, just read these paragraphs and you're fine.
Okay, great. Well, thanks. I hope we can continue this. So I'll invite Dana to all future meetings or clinics, and I'm sure there are always exciting things to report from the engineering front. And for today, under tips, tricks, and insights, I've prepared something more practical and more tangible. And it's actually something I worked on a while ago, but then forgot about it. But I thought that would be something interesting maybe for this audience. This is sort of what I would call a little helper, a little HDF5 helper if you do machine learning type activities. So what it's about is, and at the time I worked with someone at NCSA, and this is how this all came about. So the use case is, and if you, in machine learning, in certain parts of machine learning dealing with tons of tiny, where your training sets, so to speak, consist of tons of tiny image, audio, or video files, you typically have I/O issues depending on what kind of storage you use and so forth. So you get poor ML training performance, especially if you are doing this against a parallel file system, and even a very fast parallel file system. It's not going to matter at this point, just a gazillion of tiny objects. The metadata pressure is huge, and yeah, small reads tend not to be very fast. So the problem with that is also that people tend to use, for example, tar files. So they say, I got millions and millions of these images, and they just stick them in a tar file, and that's great. And they maybe compress that tar file even better. But then when it comes time to do machine learning, well, you haven't really helped yourself because it's compressed. So you got to uncompress the whole thing first. And then you got to untar it or reach into the file. But that is typically not set up for parallel I/O. And so there is a problem here. So how can we improve on that? And what happened is this colleague of mine, Dawei, and I, we wrote this tool called tar2h5, and I put a link here to GitHub. So all this is available on GitHub as open source. Just go help yourself. And the idea is basically to say, okay, we are going to replace a tar archive with an HDF5 archive. And you might say, well, big deal. What do we win that way? So the idea is basically, in doing that, to do several kinds of optimizations depending on what you would like to achieve. So optimizations along the following lines, and then I'll show you some of these tools in a little more detail. These images, in some use cases, these images tend to be small. And by small, I mean, yeah, our magic number for these things that we call compact data sets, 64 kilobytes. So if your images are less than 64 kilobytes, you can store them very efficiently in HDF5. What also frequently happens is that these tar archives, unbeknownst to the creator maybe, or unbeknownst to the user for sure, they contain a lot of duplicates. So in this example, it turned out, for example, that there were just tons of duplicates in these sets. You don't want that from a training perspective in machine learning anyway. You don't want the same file all over again under different names. For storage reason also, unless you use compression. But then again, if you can't selectively compress things, you're not helping yourself by throwing a lot of duplicates in there. And then, yeah, compression and parallel I/O, because in HDF5 with chunk data sets, for example, we know that we don't really have to decompress the entire file and not even the entire data set, but we can sort of pick out certain chunks and then decompress them at the chunk level. Now, what are some of the tools that are included in this package? So if you come here, it looks like this. We have basically two testing tools to inspect your tar archive, and in a way to give you an idea which of these tools might be the most appropriate for you. So there is an archive checker, which is basically a tool that without untarring your inventory, basically looks at the tar file. It looks at things like how big are the files in your tar archive if you were to untar them. It also looks at potential duplicates and things like that. So it's really just a diagnostic tool. And then there is a second file if you think or you heard or you suspect that most of the objects in your, or in fact all of the objects in your tar archive are less than 64 kilobytes. There is a separate checker for that. It's called Archive Checker 64K that basically says, hey, good news, like diff, for example. If diff doesn't return anything, that means the things that you are comparing identical. So if you run the Archive Checker 64K and it returns nothing, it just says, yeah, good news, everything is less than 64 kilobytes. And then there are sort of, these are the actual tools that would convert a tar archive into an HDF5 file. There is this, what I called the H5 Compactor. So this is in a situation where Archive Checker returns nothing and says, yeah, all the objects are less than 64 kilobytes. So in that case, the H5 Compactor would basically go in there and create per object, per image in the original tar archive, a compact data set, and the name of that data set, it would use the name of that file included in the tar archive as the name of that data set name. By the way, which reminds me, the archive checker actually also checks for duplicates. So it will actually alert you to potential duplicates in a tar archive. And you might say, okay, what happens if I have duplicates? What is the H5 Compactor going to do? Well, what the H5 Compactor is going to do is, indeed, it's going to create multiple copies of that same object. But then if you say, oh, I didn't know there were duplicates, and I would prefer an HDF5 file that does not contain any duplicates, there is this tool called H5 Compactor SHOR1. And because in that case, we basically established that two files are identical based on the SHOR1 hash. And so the only difference between the H5 Compactor and the H5 Compactor SHOR1 is that if we know that there are duplicates, rather than using the name of the object in the tar archive, it will actually use the SHOR1 hash string representation as the name of that compact data set, and that way it will eliminate all these duplicates. And yeah, that might be helpful. But the assumption here is also that, yeah, our objects are less than 64 kilobytes. And then there is a third tool, which we call the H5 Shreddle, where the question is, okay, unfortunately, it turns out that many of my objects or some of my objects are actually greater than 64 kilobytes, so that compact representation would not apply. What we do in this case is basically we generate one large byte array where we basically concatenate the bytes from all the files in your tar archive, and then store a second data set in which we store the offset where a given byte stream for a given file begins. And we also store an array of names where we preserve the name, the original name of that object in a tar archive. And then, of course, you can apply compression to all these data sets, to the original byte data set, to the data set of offsets, and to the data set of names. And that's it. And so he in his project used this tool with great success in terms of that the learning rate went up, or the I/O performance during the training phase improved. I forgot if he mentions they wrote a paper actually with a group. So here are some screenshots of what the HDF5 file looks like if you use a tool like he used HDF Compass to look at the file. So this might be, for example, compact, where the file name is really the dataset name, and this is stored as a compact dataset. Or if you do the SHA-1 hash as the name, then you would see these hexadecimal looking type strings, but they are fixed size, of course, because the SHA-1 hash sum is a fixed size. And then in the case of the shredder, right, we have to keep track of the bytes of the images. In this case, the bytes, the offsets where a given byte stream starts, and then the same thing for names. We have to keep track of the names and the offset where a given name begins or ends. And so it's just a simple tool, but it serves a very specific purpose and might be useful to someone out there. Little helpers for ML, and there are others, but here's a start. And unfortunately, we are out of time. Thanks for coming, and we will be looking for many other ways to sort of I don't like this personally if this is more of a monologue. I really want more engagement, involvement, people asking questions, commenting, having others chime in. Maybe in the future, if you have something cool that you would like to share with the community, by all means. And of course, it helps if you send me an email or leave a comment in the Google Doc, then we can arrange this easily to give you, just let me know if you need 10 minutes to show something cool, by all means. That's what it's all about.
Gerd,
okay.
Just
Elena, sorry, you are muted.
There was very nice talk by Alexander about S3 driver and performance results. I think it should be shared here. Yep.
I'll bring that up. And maybe we were thinking about maybe even having a separate webinar. And definitely once the ESIP recording is available, share it, but maybe also have him repeat it.
Right, because results are very good, and we should, make this knowledge more accessible.
Yeah, definitely. Okay, thanks for coming. Take care. Have a nice week. Bye.